Yep.
Okay, so welcome to What's Up Over Edmonton for the month of August 2022. My name is Jeff Robertson, and I'm a member of the Royal Astronomical Society of Canada, Edmonton Centre. For those of you who've joined us before, there's going to be a slight change in format tonight, and it will change over the next couple months, and I will explain that at the end why we're doing that. So we always start with a picture of the Queen Elizabeth Planetarium because this is where we hope someday to have these sessions live, but we'll also still send them out over the internet. It's called What's Up Over Edmonton because the skies in Edmonton are significantly different than what you normally see in the popular astronomy publications like Sky and Telescope, Astronomy, and Sky News. They're more for Southern Canada or the central United States. And as the example I always give is, this is the summer sky on July the 5th at 11 o'clock in Toronto. And I always point to this constellation here, Scorpio, where you can see the entire constellation from its head down to its stinger. But in Edmonton, this is as high above the horizon as Scorpio ever gets. So we've geared this to show what we can see here because our skies are different. We're further north. Most of the information I use comes out of the Observer's Handbook, which is put out by the RESC every year. It is 352 pages of just about anything you want to know as an amateur astronomer for observing the sky. I also use some information out of Astronomy and Sky News magazines. So, Sky and Venus. Geez, I guess I didn't proofread that. Sky in August 2022, longer nights, and it's still warm out. So what we got, we have the end of perpetual twilight. It ended on the last day of July. We've got the Perseid meteor shower, which peaks in the middle of the month. And the planets are returning to the evening sky. Sunrise today was at 5:53 a.m. It will set tonight at 9:26. And as perpetual twilight is ending, night officially begins, as when the sun is below the horizon enough that the sky becomes completely dark. And that happens at 12:45. On the last day of the month, the sun rises at 6:41. It sets at 8:25, and night begins at 10:39 p.m. So we'll go to the planetarium portion, and as always, I have pre-recorded this, and it is incorporating some of the changes I talked about in the format, which you may notice. Let's get started at looking at what we can see in the sky in the month of August. So we'll start with a sunset. And the stars start to come out as the sky gets dark. I'm sure some of you have noticed that the sun is starting to move south again. This is where the sun was when it set a month ago on July the 3rd. And here it is tonight on August the 3rd. So here's the view tonight about 10:30, and we have a waxing moon, and it is in the constellation Virgo, about 3 degrees from the bright star Spica. And tomorrow, say about 4:30, between 3:30 and 4:30, the moon will be high enough that if you have a small telescope or larger, you can view one of my favorite objects on the moon, the lunar X. It starts to be visible just before 2 o'clock, but at that time the moon is pretty low on the horizon. So 3:30, 4:30, 5 o'clock, the moon will be fairly well up in the sky, and you can view the daytime lunar X. Now, for the last couple months, we haven't had any planets in the evening sky, but that is changing now in August, because at 10:30 tonight, you look into the east-southeast and you can see Saturn coming up. There it is there. Let's just zoom in. There we go. Saturn and its rings with a nice tilt. You can see a nice display of Saturn's rings. Now, Saturn reaches opposition on the 14th of this month. And when I say opposition, that is when the Sun, the Earth, and the planet are all in a line, which means when the Sun goes down, Saturn is rising. And every day after that, Saturn will rise a little bit before the Sun goes down. Also, we've got other planets coming up, joining Saturn as the night goes on. We've got Neptune, Jupiter, Uranus, and even Mars is up by midnight. And if you stay up later into the night, and here I've stopped the clock at about 2:30 on the 15th, you have a nice parade of planets across the sky. Similar to what, well, pretty much similar to what we were seeing in the morning sky, minus Venus. Now, Jupiter reaches opposition at the end of September, but it is already above the horizon later on in the evening in August. And this is a simulation of Jupiter on the 15th of August at 11 o'clock. And on this night, you can, if you have a telescope and the seeing is good, you can watch shadow transits. The shadows of the big Galilean moons moving across the cloud tops of Jupiter. And we'll just let this one run here. We've got Io's shadow. Io itself is crossing in front of the planet, and then Ganymede's large shadow crossing the planet. And of course, the moon Ganymede is also visible, and you can follow it. And if you have exceptionally good seeing, you might even see the moon in front of the planet. As Jupiter moves into opposition, these shadow transits become more common. It's just the geometry lines up with the Earth and the Sun and the planet Jupiter, and we can watch these shadow transits. Give a look over at Mars. It's getting brighter every month, moving toward a really nice opposition near the end of the year. Certainly through binoculars, Mars will show off its orangey red color. And it is also near Uranus and the Pleiades. So we've got kind of a squash triangle here on the night of the 13th. I should also mention that Mercury is in the evening sky, but it is very, very low for this appearance. Here on the 14th, the same day Saturn is at opposition, Mercury is only 1.5 degrees above the horizon. So you would need a clear, flat horizon and a pair of binoculars to have any hope of seeing Mercury. Now, on the night of the 12th into the morning of the 13th is the peak of the Perseid meteor shower. So let's just move over here. And this is the constellation Perseus, the hero, and he's teamed up with his faithful steed Pegasus, the chained maiden Andromeda, Cassiopeia, who is bragging, upset the gods and started the whole problem with having her daughter sacrificed to a sea monster. But anyway, that's another story. Um, so the Perseid meteor shower emanates from the constellation Perseus. And there's the radiant right there. And you can expect on a good night maybe 60, 70 meteors an hour. However, we've got a problem. We got a lot of light pollution, and the light pollution is this guy right here, an almost full moon. The moon was full on the 11th, so it's going to be pretty bright, and it's going to wash out a lot of the fainter meteors, especially if you're in the city. If you're in the city, you might be lucky to see, 10 an hour. But if you definitely go out of town, you will see more meteors. They will all seem to, if you followed their trails back, they would all come from this point right here, the radiant, and they'll go all over the sky. They'll go east, west, south, north, all over the place. So get a lawn chair. Those gravity chairs are really good. You can lean back and watch the sky, bring lots of bug spray, dress warm, bring a thermos of coffee or hot chocolate, and just enjoy the show. So looking at the stars in the night sky, we see that Ursa Major, the Great Bear, or if you will, the Big Dipper, is swung down from its high point in the spring and is coming closer to the northern horizon. I've set the time here for the middle of the month, so this is the 15th, just after midnight. The Pleiades is above the horizon, low in the northeast, and echoing, I guess, that fall is coming. Of course, we have the bright star Arcturus in the constellation Bootes, which you find by following the handle of the Dipper. And I pointed this out before, but we have Hercules with the keystone, and if you zoom in with a pair of binoculars, you can clearly make out M13, the great globular cluster in Hercules, which is a collection of tens of thousands of stars, about 20,000 light years from Earth. And swinging over to constellation Lyrae, and Cygnus the Swan, and Aquila the Eagle. And if we part of the summer triangles, there it is, the summer triangle with the brightest star Vega, Deneb, and Altair. These shapes are called asterisms. They're not true constellations. They just look like familiar shapes, like the keystone here in Hercules, the great square of Pegasus, the W of Cassiopeia. And here's an interesting one. If you have a clear view to the south, because this one is really, really low. And this is the Teapot asterism, which is part of the constellation Sagittarius. Now, if we make that little drawing disappear, you can kind of make out a handle and a top and a spout here. And there's our line drawing of the Teapot again. And it lies along the southern Milky Way. And the more imaginative of us see the cloud of the Milky Way as steam coming off the Teapot. The drawing of the Teapot isn't actually part of the constellation Sagittarius when you see it in an astronomy book. The constellation stars are this. And the people that named the constellation Sagittarius pictured a centaur with a bow and arrow, so he's an archer. For those of you with telescopes, there are a lot of Messier objects clumped into this area around Sagittarius. There's the Lagoon and Trifid nebulas. There's the Eagle Nebula, the Omega Nebula, Sagittarius cluster. All sorts of different objects that you can look at and examine through a telescope. For example, M25 is a open cluster. M18, also known as the Black Swan cluster. There's M22, the Sagittarius cluster, a globular cluster. Similar idea to the Great Globular in Hercules, but a bit smaller, but still containing tens of thousands of stars. And then M8 and M20, two good objects for astrophotographers, the Lagoon Nebula down here, and the Trifid, pardon me, the Trifid Nebula up here. Of course, looking at them through a telescope, they're not going to be all colorful like that. They're going to be kind of a gray-green color. So that's what I've got for August, and we'll have a little pause for questions. I should mention a couple of things. I didn't mention anything about Venus because it's really low in the eastern sky. It rises only 45 to 30 minutes before the sun, and it's really difficult to see. And it's going to hang out very low on the eastern horizon until it goes into superior conjunction with the sun. That is, it'll swing around behind the sun, and then it'll reemerge in the morning, or pardon me, in the evening sky after that. So I didn't mention it because it's very, very difficult to see now. Now, I went with the handbook for the dates for the Perseids, and the handbook says the 12th and the 13th, but other things I've looked at said it's the 11th and 12th, like the night of the 11th, the morning of the 12th. I went with the morning of the evening of the 12th, morning of the 13th. But either way, the Earth is plowing through that cloud of debris left behind by Comet Swift-Tuttle. So either night should produce some meteors. As I mentioned, Saturn is already up. Last night I was staring out my bedroom window at around 11:30, and I could see Saturn, very clearly. And then I had to get up at about 3 in the morning, and I was wandering around and looked out the window, and oh, there was Jupiter, very bright in the sky, and Mars was there as well. So the planets are returning after a hiatus from the evening sky. Are there any questions? Oh, I have a chat here. Let's have a look here. When is the meteor? Oh, okay. Yeah, I just answered that. So some, as I say, some publications say night of the 11th, morning of the 12th. The handbook says night of the 12th, morning of the 13th. So get out both nights. Anything else? Okay, I'll continue on.
What do you see when you look at the moon? When it's full and round, do you see a balloon? Does it look like a cookie with the bite taken out? What do you see when you look at the moon?
Okay, first quarter moon is on August the 5th. The full moon is on August the 11th, which is why the Perseids are going to be kind of washed out. Full moon for August is known as the Sturgeon moon, has a number of different names throughout the world. It's called the dispute moon. I have no idea why it's called that. The lynx moon, the grain moon, the lightning moon. The Cree call it the young ducks begin to fly moon. And the word is up and I'm not even going to try. Sorry. The last quarter moon is on the 19th, actually in Edmonton. It actually occurs on the 18th at 10:36 p.m. 19th is what I took out of the book, and it happens at 36 minutes after midnight Eastern time. So I should have changed that. But so technically it's on the 18th in Edmonton. And on August the 27th, the moon is new. Now, normally I take a feature out of the Observe the Moon certificate program. I'm not going to do that today. I'm going to talk about a feature of the moon. And it's libration, or what I call the 59% solution. And I call it that because from Earth, we can see 59% of the moon's surface. Now, you may say, if the moon's orbital period is the same as its rotation and it's tidally locked, which it is, how can we see more than 50% of its surface? And the answer is libration. Now, here's a couple pictures that I took of the moon using the same equipment from the same location, namely my backyard. And I draw your attention to these two features here, the Mare Crisium, or the Sea of Crisis. The image on the left, the Maria, is near the edge of the moon, of the eastern edge of the moon. And on the right, it's further away from the edge. And the reason is libration. Libration is the effect of two things. It's the elliptical nature of the moon's orbit and its tilt relative to the orbit of the Earth. And because the moon's orbit is elliptical, it means its orbital speed around the Earth varies over time. And when it's closest to our planet at perigee, its speed is highest. And when it's furthest from Earth at apogee, its orbital speed is lowest. And this variation allows us to peek around the eastern and western limbs of the moon. And over time, it means that some features are only visible during a favorable libration. Now, not only can you peek around the eastern and western edges of the moon, you can look over the top and the bottom. And this is because the moon's orbit around the Earth is tilted about 5 degrees to the ecliptic, which causes the moon to move above and below the ecliptic. And when it's above the ecliptic, we can peek at the southern poles of the moon, and when it's below the ecliptic, we can peek at its north pole. This 5-degree tilt is also why we don't get eclipses every month, because the moon has to be full or new when it passes over the ecliptic. We call those nodes. So, and together with these effects, we see 59% of the moon's surface, which is 9% more than if the moon was originally locked to the Earth. So over the month, the moon appears to wobble as viewed from the Earth. And I have a little video here. Okay, so that's just a short part of a video I got. It's the whole thing's actually about 8 minutes long, but you get the idea. Now, the on the RASC national calendar, which they put out every year, they show the libration points of the moon for every day of each month. And that little dot there you can see next to the moon. There's another one there. There's another one there. That shows the points that are pointed toward the Earth, the libration points. And over the month, the moon, as you saw in that video, it kind of rocks back and forth and up and down. So sometimes you can see craters on the moon's south pole where the US wants to build their moon base. And sometimes you can see the edge of the Oriental Sea, which is on the moon's western edge. Kind of an interesting story about how they realized that there was actually a big impact basin on the western edge of the moon, because they didn't realize it. Even with libration, you couldn't really see the whole thing. And they never actually got a view until they had satellites or probes orbiting the moon. But they would take pictures of the moon and then they would post them on a big sphere. And because of foreshortening around the edge, when they walked around to the edge of the sphere, to the edge of where the photographs would end, they could see, hey, this is like a big, what they thought was just a big ridge was actually a series of ridges on the edge of this Mare Oriental. So constellation this month is Corona Borealis, or the Northern Crown. And there it is there. There's a drawing of it. And there's what people imagined it looked like, a crown in space. It's a very small constellation. It's located between Hercules and Bootes here. And it was mapped by the 2nd century astronomer Ptolemy. And he cataloged 22 constellations at the time from his home location in Greece. And it remained as one of the 88 modern constellations when the International Astronomical Union decided on what's constellation and what's not. The stars that make up the semicircle vary in brightness from magnitude 2.2 to magnitude 4.6. So it's not a really bright constellation. To see it all, you really have to be out of the city. They can all be seen with the naked eye out of the city lights. The stars vary in distance from 75 light years to 473 light years, and the constellation is only about 8 degrees across, so the diameter of 16 full moons. So if you held your fist at arm's length, that is about 10 degrees, so the Corona Borealis would probably go to about the 3rd knuckle. There's no deep sky objects in the constellation that can be seen without a large telescope or taking a long exposure astrophotograph, but it's been determined at least 5 of the stars in the constellation have planets, and one star has a recurring nova that was seen in 1866 and again in 1946, and that is where a star flared up to extremely bright from where it normally sits. And there's a photograph of the constellation. Now, the mythology of the constellation is kind of interesting. It's actually why I picked it. So it relates to the story of Ariadne and the Minotaur. The Minotaur was a creature with the head of a bull and the body of a man, and was terrorizing the residents of Crete. And the god Dionysus gave the crown to Ariadne, who in turn gave it to Theseus. after he arrived in Crete to kill the Minotaur. The hero used the crown's light because the Minotaur lived in a labyrinth, and he used the crown's light to kill the Minotaur, and then escape out of the labyrinth. And Dionysius set the crown into the heavens. That's one of the stories from the Greek mythology, but it's not the only story. Other cultures have stories, and I like this one a lot better. So we're going to flip the constellation around. And this is a story of this constellation as told by the Cree people who live around here. There was a young man named Tecum who had 7 uncles, and the 7 uncles went to hunt for food as it was a time of scarcity. Tecum wanted to go with them, but the uncles decided he should stay behind. They would return in 3 days. After 3 days, they hadn't returned, so Tecum went to look for them. He followed their trail into the evening and came to a place where they'd camped. All Tecum found was an empty shelter with nothing in it but 7 rocks. It was getting dark, so he decided to spend the night and continue his search in the morning. And that night, the uncles came to him in a dream. They had encountered a giant who invited the 7 hunters to spend the night with him and rest. And in the morning, he'd tell them where to find fresh game. And as he slept, the giant crept into their dreams and took their spirits. He did this because he wanted to eat their bodies, but he couldn't if the spirits were still in the bodies. So he transferred their 7 spirits into 7 rocks, which he knew would hold them. The uncles told Tecum how to free their spirits, but they could not return in human form. They would, however, visit him if he did what they told him. He instructed them to build a domed lodge from branches and animal hides. He built a fire outside the lodge, placed the 7 stones in the fire until they glowed red hot. Then he moved the rocks into the lodge, closed the door so it was completely dark. Then he sang and prayed and splashed water on the hot rocks, which released the uncle's spirits. He saw their spirits as lights, and they were born again in the dome lodge. And this is the Cree story of Matusian, the sweat lodge. And you can clearly see the shape of a sweat lodge. So that is another story, and I think it's far more interesting than the Greek one. And there's a picture. So this is space history. I always pick an item that happened, it has an anniversary date divisible by 5, what happened in this month. So we're going to talk about Venus. And as you know, Venus is the 2nd planet from the sun. There's the moon, there's Venus right there. It's a picture I took a couple of years ago. I thought it made a nice photo. And it's known as the morning or evening star, depending on when it's visible. And it's the 3rd brightest object in the sky after the sun and the moon. And it does get mistaken for aircraft and UFOs. And I've noticed it attracts a lot of attention from the public when it's near the moon, like in this photograph. Normally, people may just look in the sky and not even see it. But when it's next to the moon, it gets people's attention. Since the invention of the telescope, it has been known that Venus goes through phases like the moon, proving that it revolves around the sun and does not revolve around the Earth, as was previously thought. It's so bright because it's covered in thick clouds, and the surface of the planet has never been seen from Earth. And before the age of space travel, not a lot was known about the planet. We did know a few things. We knew its orbital period. We knew how big it was. It's about the same size as the Earth, just a little bit smaller, and we knew its mass. But we could only guess how long its day was. Some people took guesses that it had a day similar to Earth. Some it was a few days longer. It turns out its day is longer than its year. It has a very slow rotation. And because it was roughly the same size as Earth, and it was in the sun's habitable zone. That is the zone where liquid water could exist on the surface. All sorts of speculation of it being Earth's twin, so where it was floating around. And a lot of sci-fi movies I watched from the made in the 50s and early 60s had creatures in Venus. There was one movie, a Ray Harryhausen stop animation movie, I think it was called 20 Million Miles to Earth, where a craft came back from Venus carrying a little creature which grew into a big giant. There were people who claimed to have talked to Venusians. And when I was a kid, I remember going to see a movie called Have Rocket Will Travel with the Three Stooges, and they went to Venus and found people there, robots, and giant tarantulas. Like I say, we didn't know a lot about Venus. There was a lot of speculation about Venus, and Carl Sagan, who I've mentioned before, had an illustration about that speculation. Because he said, here was the speculation. I can't see a thing on the surface of Venus. Why not? And well, because it's covered in clouds, a dense layer of clouds. Well, what are clouds made out of? Well, they're made out of water, of course. Therefore, Venus must have an awful lot of water on it. Therefore, the surface must be wet. Well, if the surface is wet, it's probably a swamp. And if there's a swamp, there's trees and ferns. And if there's ferns, there might be dinosaurs. So the observation was, I can't see a thing on Venus, and the conclusion was dinosaurs. So you can see how that would kind of get away on people. So we're talking about the very first successful interplanetary probe, Mariner 2, which was launched 60 years ago this month. Now, Mariner 2 was based on the design of the first generation of Ranger spacecraft, which the Jet Propulsion Laboratory, which handled the program, were shooting at the moon. So they took the basic design of the Ranger first generation, which this is at there, and they built this. This is Mariner 2. And you can see the similarities, and you can also see it's quite a small spacecraft compared to what they're sending up today. Carried 6 instruments to study Venus and its atmosphere, as well as the interplanetary environment. There was a microwave radiometer and an infrared radiometer, which are the 2 key instruments. A micrometeorite sensor, a solar plasma sensor, a charged particle sensor, and a magnetometer. It carried no camera. They felt, well, it's all covered in clouds. We're not going to see anything anyway. It was 3.7 meters tall, and it was 5 meters across with its solar panels deployed, and it weighed just a little bit over 200 kilograms. So it was launched on August 26, 1962, on top of a Atlas Agena rocket. Now, I say Mariner 2 because there was a Mariner 1, and it was launched on July 22nd, 62, but it suffered a booster failure. And the only thing it managed to explore was the bottom of the Atlantic Ocean. Took 4 months to get to Venus. And along the way, it did have some power problems. But by the time it reached Venus, it had sufficient power to complete its mission. Along the way, it measured the solar wind, cosmic rays, and interplanetary dust, which it found was not as prevalent as was thought. And there's just an artist's conception of the craft in space, and it communicated through this high gain antenna here. It also had an omni antenna at the top of it here, and the 2 solar panels. Now, Mariner 2, as I said, Took 4 months to get there. It swung past Venus on December the 14th, 1962. Now, it had been determined by radio astronomy that Venus was radiating a lot of heat. Now, the question was, is it the atmosphere that was hot, like the clouds, or was the planet itself hot? And those who fancied the Venus as Earth twins and with trees and dinosaurs, etc., they figured or hoped that it was the cloud tops that were hot. And they would use the microwave radiometer and the infrared radiometer to give them that answer. So as it swung by the planet, it used these instruments to sweep the planet. Now, if the radiometers showed that the limb of the planet was bright, it would mean that and the center of the planet was dark, it would mean that the cloud tops were hot and the surface was cooler. However, if the limb was dark and the center of the planet was bright, it meant the surface was hot and the clouds were cool. So, as I said, on December 14th, it scanned the planet with a pair of radiometers, and it revealed that Venus had cool clouds and an extremely hot surface. It passed 34,773 kilometers from Venus. It detected no magnetic field, but it revealed that the atmosphere was not made out of water vapor, was made out of carbon dioxide. And like I say, the planet was extremely hot. After it swung by the planet, it went into a solar orbit, and the last transmission was received on January 3rd, 1963. Now, it wouldn't be until the 1970s when the Soviet Venera probes, which would orbit and land on the planet, before the true extent of what a hellish place Venus was would be revealed. And this is a picture from the surface of Venus taken by a Venera spacecraft. The US's Magellan radar mapper would provide a true picture of the surface in the 1990s by using radar to map the surface of the planet underneath the thick clouds. Turned out that Venus has a surface temperature of 462 degrees Celsius. That's hot enough to melt lead. Its atmospheric pressure on the surface is 92 bars, equal to 900 meters underwater. And the atmosphere is 96% carbon dioxide with a bit of nitrogen and other gases. And the clouds also contain a large amount of sulfuric acid. It does rain sulfuric acid on Venus, but it never reaches the surface. It evaporates before it gets to the surface just because of the intense heat. But up in the cooler areas of the clouds, it does rain sulfuric acid. So it's not exactly a great place to be or visit. Mariner 2 is a triumph for the Jet Propulsion Laboratory and NASA. JPL was actually having a lot of trouble with the Ranger program. Ranger program's a whole other story, and I may talk about that later in some other session, because they shot 9 of these things towards the moon, and only Rangers 7, 8, and 9 actually worked the way they were supposed to. So Mariner 2 was a tremendous success, so much so that at the 1963 Rose Bowl parade in JPL's hometown of Pasadena, they made Dr. Pickering, who was head of JPL at the time, the parade marshal, and they had this nice float saluting Mariner 2, the world's first successful probe to another planet. Always reference heavensabove.com. It's a great source of all things astronomical. It's got star maps. It's got satellite passes, passes the International Space Station, comets, you name it. You just have to set in your location and it will produce you a map either that night or that particular hour you happen to be asking. It will produce a star map for you. Next What's Up is going to be on Wednesday, August 31st. Hope I've recovered from my surgery enough to put it together. Already started working on it. The next meeting of the RASC Edmonton Center will be on September the 12th. Now, I mentioned at the beginning that we're going to change some of the format, and this is because introduction to stargazing, which Alistair Ling has been doing for the last several months, over a year. He's stepping away from that. And we've been talking, and we're thinking we're going to try and merge these two sessions together. Introduction to stargazing goes over the things you need for the beginner observer certificate, and Berta Beltran does a lot of that, and I've talked to her and she seems to be on board with it, but she's over in Europe with her family right now. So you may have noticed that I didn't have the other highlights at the end of the talk, which I normally did. I incorporated that into the planetarium session, and the constellation and moon section will probably disappear, and that will be replaced with the introduction to stargazing material. So we'll see how that works out. And with that, I will say thank you. And if there are any questions or comments, I will take them now. How will we know if an exoplanet may have life? Good question. They think with the web, they might be able to actually take some readings of the atmosphere and see if it's something that could support life as we know it. You know, they have detected various gases already with some of our telescopes, but to determine if it actually has life or not, that's a good question. Methane is a good indicator of life, but it's not the only thing that makes life, or life isn't the only thing that makes methane. Yeah, that's a good question. I don't know. And what's this? What will be the direction of travel of the meteor? The meteors are going to go all over the place. They'll go left, right, up, down. But if you follow the track of the meteors, they'll all seem to come back to that point in the radiant, just off to the left of the constellation Perseus. So you would look, they would go all over the sky. So if you're good, if you do go out of town and you're laying back in your lawn chairs, and take more than one person with you, and you can be facing different directions, and you can see, make sure you don't miss any. They are going to be a bit tough to see because of the moon. And thank you very much. Is there any other questions, comments, tomatoes, rotten fruit, anything? Okay. Thank you for the thumbs up. Okay, well, we finished kind of early. And that's another thing I've tried to do this time is make particularly the planetarium session, because I do know I tend to babble on. I've tried to keep that shorter in anticipation of having the introduction to stargazing merged in, and we don't want it to turn into some sort of 2-hour snore fest. So, okay, well, if there's nothing else, I'll say thank you very much for you who attended. This is being recorded. I will place it on our YouTube channel in a day or two. And I will say, it's pretty cloudy. It's probably raining right now. I'll say thank you and good night and clear skies.
Thanks, Jeff.
Thank you.